Hi there, this is Miss Loving. I am going to walk you through your first objective for atmospheric systems. Today we are going to recognize that the sun provides energy that drives convection within the atmosphere and the ocean currents. And the sun provides this energy which affects the density of the ocean currents as well as the atmosphere. So if you have not, go ahead and copy down your essential questions and set up your wicks. And when you're ready, let's get started. So let's differentiate between climate and weather. Climate is the average weather pattern in an area over many years, most of the time hundreds of years. Whereas weather is what affects your daily life, and it is the daily changes in the atmospheric conditions affected by the pressure systems, convection currents, and the weather fronts. So if you notice, I've put a clip of the weather forecast. So that's just the daily changes. The rising and falling of the air and the water in the ocean is affected by three different factors. In the air, the three factors are the temperature, the altitude, and the humidity. In the ocean, the density is affected by the temperature, the salinity, or the amount of salt dissolved in a body of water, and the depth of the ocean water. We're going to take a look at these factors in greater detail and how they affect the convection in the air and in the water. So if you recall from many years ago, we talked about convection, that is the rising and falling of air. In the past, we've talked about mainly just the temperature being the main reason that air rises and the main reason that air cools and falls. Same thing goes for the ocean. But there are some other factors that we need to share with you and discuss. So of course, the temperature is the main factor, and so when air is warm, the molecules move very rapidly and they are spread further apart, so they are less dense, less compact, and they rise. And then when that air begins to cool, the particles begin to move more slowly and they're more tightly compacted together and they sink because they are more dense. Well, the elevation, or how high the air molecules are, or how far away they are from the Earth's surface, is another factor that affects the density of the atmosphere. So as you go higher in elevation, the air pressure decreases due to the decreased amount in particles in a given space. So if you take a look at this little clip art right here, you'll notice the closer to the Earth's surface, the more tightly compact and closer the molecules are together, and the further you go up, the further apart they are. So if you've ever been to the mountains, there's a significant difference when you're breathing because the air molecules aren't quite as dense and the air is drier. Another factor other than temperature and elevation is the humidity, or the amount of moisture that is in a given amount of air. The greater the humidity, the greater the density. If you notice, with a high relative humidity, which is typically what we experience near the coast, we have got lots of water molecules in the air, whereas in a lower relative humidity, the air is drier. I know, ladies, you'll know that on a high humidity, our hair doesn't tend to cooperate, and then on a dry, low relative humidity, our hair does cooperate. So temperature, elevation, and the humidity are the three factors that affect the density of air molecules. Now let's go ahead and take a look at the three factors that affect the density of the ocean waters, or water molecules. One of them, just like air, is the temperature. Whenever the ocean water is warm, it is going to rise to the surface of the ocean, and when it's cool, it's going to be more dense and it's going to sink down deeper into the ocean. Another factor is the salinity. The salinity is the amount of salt dissolved in water. The more salt dissolved in a given amount of water, the greater the density. So if you take a look down here at these two little cups, we have a cup of fresh water, and there is some salt in the fresh water. And you'll notice the molecules of just fresh water itself are not very close together. They're not that tightly compact. But whenever you dissolve salt into the water, just like as shown here in this little ocean water cup, the molecules are much closer together, much more dense. And so even the amount of salt can change through in an ocean depending on its location. I know that there are times of the year whenever we don't have a lot of rain and the salinity is really, really high, so the density of that ocean water is more dense. At Salt Lake, that is a lake that is full of salt water. Someone can actually float in that water very easily because the water is more dense, and that dense water is pushing upward because the water is more dense than normal. Another factor is the depth of the ocean water. I know many of us have swum to the bottom of a swimming pool and we can feel the pressure on our ears. That same thing is the pressure that we're talking about with that affects the depth. The depth affects the density because the further below sea level one goes in the ocean, the pressure of the water increases due to the increase in the water molecules and the pressure, the weight of the water on top that affects the density. So the three factors for atmosphere and oceans affects the density of the molecules. So with atmosphere, we have the temperature, the elevation, and the humidity. And that affects the wind currents that occur on the Earth's surface due to the rising and falling or sinking of particles. Remember, the less dense something is, it's going to rise above the more dense particles, and we constantly have the convection currents. Well, the same thing takes place for the ocean. The three factors that affected the density of the ocean are the temperature, the depth, and the salinity of the ocean water. With the constant rising and falling of the air in the atmosphere and the water in the ocean, these convections that are taking place drive our weather and our climate. We are all done for today, so please do not forget to go and complete your support item. You're going to need to look up on the internet and compare the direction of the ocean current movements in the northern and in the southern hemisphere. Have a great day, and we will see you at school.